Welcome. In this video, I'm going to go over the solutions to your 8-1-8-3 mini quiz on acid bases. So number one asked you to write the dissociation for the following. And so with perchloric acid, you have to look up perchlorate, and you see it's ClO4 and only has a -1 charge. So perchloric acid is HClO4. And you could have written this also just as easily. You could have just shown the perchlorate itself dissociating into H plus and then the perchlorate. Either one is fine. The key is that you have to have the double-headed arrow indicating you know it's a weak acid. And so the dissociation of propanoic acid, I gave you the formula there, CH3, CH2, COOH or CO2H, either way. And again, you could have written it without the water and just showing it's dissociating. Need the double-headed arrow. And the H plus. That would be fine as well. And then the dissociation of ammonium ion. This one, remember, ammonium is NH4 plus, so it's going to lose the hydrogen. So I could have also written this as NH3 and just the H plus. So your preference on that doesn't really matter. And the number two, for the following, identify the acid base, conjugate acid, and conjugate base for each. So what this is really asking is that you realize an acid is the hydrogen donor and the base is the hydrogen acceptor. So I can see here that H3O has accepted one, making the H2O the base. It is the C5H5NH3 that's lost a hydrogen. And I notice I've got a typo here. I still need an H2 here. It didn't lose all of them. It only lost one of them. And because the H plus came off, this is now neutral. The H3O has picked up the plus sign. So you notice I have a +1 on each side. That was what some groups struggled with, was the charges. Just like on the second one, HCO3 minus, if it gives up another hydrogen, it becomes CO3 2 minus because the plus went with the hydrogen. The C6H5NH2 becomes C6H5NH3 plus. Number three, calculate the H plus and OH minus for the following. There's actually two ways you can do this. I did it the way the book set it up for you, but few groups figured out there's actually another way which some groups consider easier, so I'll show you the alternative way as well. But the H plus, basically, pH is really, you've taken, to get pH, it's the negative log of the H plus concentration. So what that means is that your H plus concentration is 10 to the negative pH. So that's what I've done here, is I've taken my pH of 7.4, so 10 to the negative 7.4 then gives me a concentration of 3.98 times 10 to the -8, and then that's moles per decimeter cubed or moles per liter, or just capital M. The OH minus, remember Kw is equal to 1 times 10 to the -14th at 25 degrees Celsius. And so that means my H plus and OH minus are going to be equal to each other, because that's what's giving me this 10 to the -14th. So that means H plus, OH minus, the product of those have to equal the 10 to the 14th. I don't actually need this part here, so let me get this out of here. So this is what we're interested in, is that I know the product of these two has to equal the 10 to the -14th. So what I've done is 1 times 10 to the -14th has to equal the 3.98 times 10 to the -8 times the OH concentration. So I've moved this over. And then this will give me my OH concentration of 2.51 times 10 to the -7th. Now the other way some folks did this, and this is just fine, is they realized that pH plus pOH have to add up to 14. So if my pH is 7.4, I can take 14 minus 7.4, and I end up with 6.6, and that's my pOH. So then I can take 10 to the -6.6 and that should be my OH minus concentration, and that will give me the same number of 2.51 times 10 to the minus 7th moles. So look at the other ones here. Again, H plus is going to be 10 to the negative 15.3. You have to go ahead and calculate that out and get it into a concentration, 5.01 times 10 to the minus 16th. I then just took 1 times 10 to the minus 14th and divided by that concentration. But if I had taken 14 minus 15.3, I would get a negative 1.3. And if I take 10 to the negative 1.3, when I go ahead and punch that into my calculator, I get 19.95 or 20 molar, just like I did doing it the other way. So then looking at the last one, pH is a negative 1. So the H plus concentration is 10 to the negative 1, or 10 molar. And then my OH, I took 10 to the minus 14th over the 10 to the 1, and that's how I got 10 to the minus 15th. But again, I could have taken 14 minus a minus 1 and gotten my POH of 15, and then taken 10 to the negative 15 to get my OH concentration. Either way should yield you the same result. Number 3, I was a little surprised how many groups struggled to tell me what ions or species are present in 0.25 molar solutions of the following acids. Basically, I'm asking you, what does it dissociate into? So I'm going to have H plus on this one and Cn minus, and H2SO4 is going to give me 2H plus for every sulfate, SO4 2 minus. So then if I have 0.25 molar solutions of each, for my first one, my 0.25 molar solution of HCN gives me 0.25 molar H plus and 0.25 molar Cn minus. So my pH is just going to be the negative log of 0.250, or 0.602 is going to be my pH. Whereas with my H2SO4, because I get 2 H plus for each one, I have to double that 0.25 molar concentration to 0.5, and when I take the negative log of 0.5, I get a pH of 0.301 for the second one. And then number 4, a 0.056 gram sample of acetic acid is added to enough water to make a 50 milliliter sample. Calculate H plus and pH for the sample. Well, I need to know my concentration of H plus in there, so I have to take my 0.0560 grams of acetic acid, divide by the molar mass of acetic acid, which happens to be 60.06. So we're really talking 9.3 times 10 to the minus 4 moles of H plus coming from that acetic acid. I divide that by the volume of it, which is only 0.05 liters. And so we're talking about a 0.0186 molar solution of acetic acid. And when I take the negative log of 0.186, I get 1.7. Actually, I shouldn't have an M there. 1.7 is my pH. And then 5, explain why the pH of water at 25 degrees is equal to 7. Two things I was looking for there. Because water self-ionizes. Okay, that's why. It's because water falls apart, gives you H plus and OH minus. If it didn't self-ionize, there'd be no H plus concentration. And at 25 degrees, that ionization constant is equal to 10 to the minus 14. And H plus and OH minus concentrations have to be equal, meaning the pH will be 7 as well as the POH. And then part B, at 50 degrees, the Kw goes up to 5.47 times 10 to the minus 14th from the 1 times 10 to the minus 14th at 25. What does that indicate about the enthalpy value? Well, the Kw is increasing with temperature, so that indicates the equilibrium moved right, which means the enthalpy is positive or it's an endothermic reaction.